Hello everyone. Today we are going to look at binomial expansion. This is a topic from Pure Math 1 and this is grade AS levels. We are going to do some more videos on topics of AS levels. So this is the first video on this channel and yep, let's get on to it. When we talk about binomial expansion, let's break down the word binomial first of all. What is a binomial? I think at AS levels, a lot of us would be aware, but just giving a brief idea about this. Whenever you look at algebraic expressions, this is an algebraic expressions and the number of terms here are 3. So this is a 3-term expression. When you look at an expression which has only 2 terms, such an expression is called binomial expression. And we are going to try and understand how to do expansions related to binomial terms. Okay, so something as basic as a plus b the whole squared expansion is related to expanding the brackets. And when we say expanding the brackets, we are trying to multiply out the brackets. When we say a plus b the whole squared, we historically do it this way: a plus b multiplied with a plus b, you have a times a plus b times a plus b, and this makes it a square plus ab plus ab plus b squared, making it a squared plus 2ab plus b squared. Okay, fine. Similarly, if you have a plus b the whole cubed, a plus b the whole cubed would mean a plus b multiplied with a plus b multiplied with a plus b, that is a plus b the whole cubed. We already saw what is the expansion of a plus b and a plus b. So I would directly take this over here and write it as a square plus 2ab plus b squared times a plus b. Now what I am going to do is I am going to multiply out each term of bracket 1 with each term of bracket 2, which will look somewhat like this: plus 2ab times a plus b plus b squared times a plus b. This makes it a cube plus a square b plus 2a square b plus 2ab squared plus ab squared plus b cubed. So I'm going to collect the like terms: a square b, those are like terms. Similarly, ab square and ab square, those are also like terms, which means a square b plus 2ab square makes it 3a squared b plus 2ab square plus ab square makes it 3ab squared plus b cubed. So that is the expansion of a plus b the whole cubed. Now let us write it over here: a plus b the whole squared was a square plus 2ab plus b squared. I am going to write out the coefficients of the variables here. When you see nothing over here, what does it mean? It means it's 1. The coefficient over here or the constant over here is 2, and the coefficient over here, again nothing, means 1. Similarly, if I have a plus b the whole cubed, I have already expanded that, and if you check that out, it will look somewhat like this. Right? Again, we are going to look at the coefficients. Yes. What are the coefficients looking as? The first one, nothing, means 1. Second one is 3, next one is again 3, and the last one is 1. Yeah. If I had only a plus b and a plus b was raised to 1, suppose, it would remain as a plus b. And if I am looking at coefficients of a plus b, coefficient of a and coefficient of b, what is the coefficient of a over here? It is 1, and coefficient of b is also 1. Okay. When I have expanded this, do you see a connection over here? If I add this and this 1, don't you think on addition I will get this 2 over here? Yes. Similarly, if I add this 1 and this 2, don't you think I will get this 3 over here? Similarly, 2 and 1, if I add, I'll get this 3 over here, right? So addition of these two gives me 2 over here, addition of these two gives me 3 over here, addition of these two gives me 3 over here, correct? Which means this is kind of forming a pattern, which means if I were to expand a plus b the whole raised to 4, at least I know what would the coefficients look like, because it seems that the pattern is continuing, right? For example, if I were to add this and this, it would give me the next one, which comes out as 4. Again, this and this addition gives me 6, this and this addition gives me 4, this was also 4, and the ends would be 1, correct? So let me write that out for you. When you add these two, you get 4, you add these two, you get 6, you add these two, you get 4, and the ends would remain 1 and 1, because that is continuing as it is, correct? So there's no change over there. So that's the pattern that we are observing, which means the first term will have coefficient 1, second term will have coefficient 4, third will have coefficient 6, fourth will have coefficient 4, fifth will have coefficient 1, right? So let us expand this. Since it is a plus b the whole raised to 4, yeah, a raised to 4 coefficient stays 1, correct? Next one, the coefficient becomes 4. For the next one, the coefficient becomes 6. For the next one, the coefficient becomes 4. And for the last one, it becomes b raised to 4, which is again coefficient 1, right? You might be wondering, why have I left these spaces blank? That's because we have to further observe some ideas over here, and it's not easy just looking at numbers that, okay, if that is the pattern for numbers, what is the pattern for a and b? We have not figured out the pattern for a and b yet. Do you see a has taken, to start with, the power 3 in a plus b the whole raised to 3? A has taken the power 3 in the first term, the power has reduced by 1 in the second term, it has further reduced by 1 in the next term, and it has further reduced to such an extent that it is no more visible. Yeah, can I say if nothing is there, that means there is a 1 over here? Yes. Okay, so that is one observation, that powers of a are going to go on decreasing, which means in the next term power of a will become a cube, in the next one it will become a squared, in the next one it should become a, and in the last one a raised to 0, which is 1. Okay, now similar thing we are going to try and observe for b. If you observe, b has taken the power over here as 3, and then there's 2, then there is 1, and then there is none, correct? So if we look at 4 over here, this should become what? It will become 3. The next one will become 2. Next one will become 1, which means just B, and the last one will be 0. Do you observe the pattern over here? Which means if you are good with identifying this pattern, that means you will be able to now expand a plus b the whole raised to 5 on your own. Yes, you can pause the video over here and try to expand it from the logic that we have learned. Yes, perfect. I'm going to go away and go ahead and write the expansion now. From the pattern that I have seen over here above, I'm going to first continue that pattern. The pattern says that I'm going to add these two, these two, these two, these two, and in the ends I will be writing the 1, which is by default it stays as 1. Okay, 4 plus 1, this is going to be added, that becomes 5. 6 plus 4 added gives me 10. 6 plus 4 added gives me another 10. 4 plus 1 added gives me 5. So these are going to be my coefficients for a plus b the whole raised to 5, and accordingly the highest power goes to the first term first, a raised to 5, yes, plus a raised to 4 plus a raised to 3 plus a raised to 2 plus a plus b raised to 5. See, a raised to 1 जहाँ पे आ गया, after that it's going to be a raised to 0, which means b has to take the highest power over there. Now we are going to go the reverse way and decrease the power of b. This will be b raised to 4, this will be b raised to 3, 2, 1. Okay. Next step is to incorporate the coefficients in that expansion. So how do I incorporate the coefficients? The first one stays 1, which is as it is over here. Next one is 5, so I'm going to put 5 over there. The next one should be this one, which is 10, so it should be 10 over here. 10 for the next one as well. 5 for this one, and the last one stays 1, so this one stays 1. I hope you all have also gotten the same expansion answer after you tried it on your own, looking at the pattern that we observed in the previous cases. Yeah, this pattern and this pattern. Yeah. Okay, if you have understood this idea, ideally binomial expansion is purely based on this. What are they going to do at most? They are going to change this for you, and this, instead of a and b, you can have x and 1, x and 2, x and 3, anything of that sort. Do you want to try out one of the examples of that sort? Let's say you have expansion of x plus 2 the whole raised to, you want to start with 4? I think 4 is a good number to start with. Yeah, x plus 2 the whole raised to 4. Now for expansion of 4, what is the idea? You start with giving the power 4 to the first term, x raised to 4, plus, then it becomes x raised to 3. You go on decreasing the powers of x, correct? Then x raised to 2, then x raised to 1, and then we give the highest power to the next term, that's 2 raised to 4, and then decreasing the power for 2, 2 raised to 1, correct? Now we need the coefficients. Can we go back to this part over here where we have coefficients of power 4? So coefficients of power 4 They are, for the first one it's 1, for the second one it is 4, for the third one it is 6, for the fourth one it is 4, and the last one it is 1. Okay, obviously they are not expecting you to keep it this way, they want you to simplify it. So yes, you are going to simplify it. 4 times 2 gives me 8, and that makes it a 8x cubed, plus 6 times 2 squared is 4, 6 times 4 is 24x squared, plus 4 times 2 cubed is 8, 4 times 8 is 32, and that's x along with it, and 2 raised to 4 is 16. That's your expansion for x plus 2 the whole raised to 4. Yeah, obviously you would think about what happens if you get something in terms of negative. For example, let us go to the new page. Yes, for example, if you have x minus 2 the whole raised to 5, you want to try 5, let's go for 5. Yes, and for 5, if you were to identify what are going to be the coefficients, then let's make the pattern that we had observed. 1 1 goes on to 1, and then addition of 1 and 1 gives you 2, that's 1 again. Addition of 1 and 2 gives you 3, 2 and 1 again gives you 3, in the ends you have 1. Addition gives you 4, 6, 4, in the ends you have 1. Addition gives you 5, 10, 10, 5. Towards the end you have 1. Okay, so have I reached my required expansion? Yes, it is 1, 5, 10, 10, 5, 1. Yeah. So if I were to expand x minus 2 raised to 5, what I would do is I would rather consider this as x plus something and give the negative sign to the second term, and then expand as if it was a plus b the whole raised to n. Yeah. So now obviously we start with x having the highest power, x raised to 5. Next thing is x raised to 4. Next thing is x raised to 3, x raised to 2, x, and I'm sorry, last one has to go below. Okay, fine. Next thing, obviously the last one is negative 2 raised to 5, which means the one before that should have been negative 2 raised to 4. The one before that negative 2 raised to 3. We are decreasing the power. Negative 2 raised to 2, negative 2 raised to 1, and yeah, that's it. You have to incorporate the coefficients now. First one stays 1, second one is 5, next is 10, 10, 5 and 1. So if you were to simplify this, it would look somewhat like this: 5, and then 5 times negative 2 raised to 1. Negative 2 raised to 1 is negative 2. 5 times negative 2 is negative 10x raised to 4, plus you have 10 times negative 2 raised to 2. कितना होता है बेटा? It's 4. So negative 10 times 4 makes it 40x cubed, right? What comes next? Negative 2 cubed is negative 8. Okay, so this will be negative 8 and multiplied with 10, giving you negative 80x squared. Similarly, negative 2 raised to 4 is positive 16. So 5 times 16. Obviously, you are going to use the calculator for this, but 16 5s is 80. 80x, and negative 2 raised to 5 gives you 32. So oops, my bad, negative 2 raised to 5 should give you negative 32. So this is negative 32. That's your final expansion for x minus 2 raised to 5. That's how you generally expand any binomial expansion that is in front of you, right? Now, obviously, there are other ways also to work this out. Like a lot of you would have come across something called as a formula that needs to be used for expanding this. And how do we work on this formula? Let's look at this formula in the next video. So that's it. Thank you. Hope this helps.